Hi, everybody. Hope you're having a fantastic day. We are going to do our next type of triangle congruence. But before we get started on that, we're going to review what we learned yesterday. And so just go ahead and on this first one, decide if these two triangles are congruent. And then on this second one, solve for Z using the exact same skills we used in yesterday's lesson. Okay, so we are going to start working through some different theorems, or in other words, you might hear them called as a postulate. And it basically is a rule for how to determine if things are congruent. So the two we're going to work on today are SAS, which is side, angle, side, and then ASA, which is angle, side, angle. Okay, so we're going to start with the ASA theorem, so angle, side, angle, and the rule for this one says, if two angles and the included side, which means the side between them, of one triangle are congruent to two angles and the included side of the other triangle, then the triangles are congruent. So this right here shows you a perfect example, okay? And you have to work a little bit backwards to be able to find it because we have to know for sure that this right here is 45 degrees. So yesterday we learned that we can subtract our degrees from 180. So if we take 180, if we subtract 74 and we subtract 61, we get that it is 45. Okay, and so that tells us that we have a 45 degree angle, a side that's 2.3 centimeters, and a 61 degree angle on both sides. And let me just pull up this other screen and kind of draw it in and emphasize it just a little bit more for you. So again, we said that 180 minus 74 minus 61 makes this angle be 45. And this rule says we have two angles with an included side, which means that it all is equal and it's all the exact same. So if you saw this example, it would say, yes, these are congruent due to the ASA theorem or ASA postulate. Okay, so here's another example of how they could look. Okay, so again, we'd have to prove first and foremost that angle P is equal to 110. So we'd have to take 180 and subtract 38 and 31. And it tells us that this angle right here is actually 111. So because of that, we cannot do this rule. Okay, because of that, it does not work. And so again, let me pull up this screen. If we were, because we need to look for these two angles, right? We need a 31, a 110 with a 62 in between. So we have a 31, we have a 62. So this is our question mark to be able to figure out. So if we take 180, subtract 31, and subtract 38, we actually get 111 degrees for that, which does not match our 110 degrees. So these are not congruent. Okay, and there's going to be many times where they're not going to be congruent. You just have to pay attention to the small details to make sure that you can recognize when they are and when they are not. Okay, here's two examples. Let me blow them up. Okay, this one here to the left is congruent. And again, you know that by taking 180, subtracting 72, subtracting 38. Okay. 72, 38. Okay, and this one right here, actually, I think I mixed these two up because this one right here is the not congruent one. If you take 180, subtract 72, subtract 38, you actually get 70 degrees for this angle right here. And it needs to be 67 degrees in order for it to be considered a congruent triangle. Let me zoom in just a little bit because it is a little bit smaller. So I took 180, subtracted 72, subtracted 38, and I found that that angle is 70. And the only way that angle side angle works here is if this angle is 67. So this is actually not congruent. Okay, so I actually messed up on that one. It's very easy to do. Like I said, you have to pay attention to all the small little details. So then that means that this one probably is going to be congruent. We have a 90-degree angle for both of those, right? That's how it would work. It looks like these sides are the same and these angles are the same. And you know that because they have the same markings. So because of that, this one would be congruent. Okay, angle, side, angle. Angle, side, angle. So that would be congruent. So on this one, when I was making my slideshow, I obviously flip-flopped our two examples. So I'm actually going to go through and fix it really fast so that if you are looking at the slideshow, you're going to realize it as you're going through it. Okay? So now I want you guys to look at these two triangles and I want you to determine, are they congruent based on angle side angle or are they not? Okay, so look at everything you have and make a determination if these two triangles are congruent. Okay, so now we're going to start, on our second one for today, which is side angle side, okay, SAS. And it says that if you have two sides and an included angle, so the angle between the two sides, if you have that on one triangle and on the other triangle, then they have to be congruent. So you notice here that we have 74 and 46 are our sides. Our included angle that's between them is 37. Same thing on this side, so that makes them be congruent. We're looking for two sides and an angle between to prove the SAS theorem. All right, so let's look at this one. This one right here has us with an angle that we don't really know, right? So we have a 45 on one side and a 43 on the other, and there's not enough information to figure out other angles, but we don't really need to. All we need is that, yes, 20 and 19 are the same, but 43 and 45 are not the same, so therefore these are not congruent. Let me just re-emphasize that by pulling this up. So again, we do have some similarities, right? We do have our two sides, but this rule says that the angle between them has to be the same. And we have a 43 and we have a 45, which means those are not congruent triangles. Okay, they have to be the same everything. All right, so let me pull these ones up a little bit larger. Okay, so we have our not congruent one over here to the side, and then our congruent one should be on the right side. So if we're looking at this, again, we have two sides that are the same, 30 and 30, 40 and 40. But we have a 90-degree angle and a 95-degree angle. And so because of that, we automatically know there is no way that they can be congruent, okay? It has to be everything the same. So if we look at this one, we have 2.5 and a 2.5, a 1.7 and a 1.7, and their included angles are equal. That one line on both sides means that those are congruent angles. So this is an example of a congruent pair of triangles using side, angle, side, and then this one is not congruent. Okay, you guys go ahead and look at this one. This is your practice. See if you can determine using side, angle, side if these are going to be congruent triangles. All right, so your answer should have been yes for that one, but I just kind of want to clarify it really quickly, okay? So we have the 30-degree or 30-millimeter side. And because they share a side, that means it for sure has to be the same. So we have our two sides. So now we're just looking at that last bit, which is that included angle. And because they have this symbol here of this one line, it means that they are equal. So we have side, angle, side, angle, side, and that is why they are congruent. All right, so I'm just going to pop up some triangles and you decide based on what you see if they are going to be congruent or not. And if they are, which theorem would you use? So just look at this really fast. Would you use angle, side, angle, or would you use side, angle, side? All right, so same on this one. How would you prove that these two are congruent? Would you use side, angle, side, or would you use angle, side, angle? All right, so that is it for the first two theorems that we're learning for triangle congruence. You do have an exit ticket in your Google Classroom that is the required assignment for today. Make a copy of the Google Doc, or if you want to do it on a piece of paper and take a picture and send it in, that's fine as well. Make sure that this gets done by the end of the class period. And again, like always, come to office hours, email or text if you're confused at all and you need any help. Have a great day.